Hello everyone, my name is Asim Mitra. I am a program manager in the Internet Information Services team. And today we'll be looking at the new security features that we have added in IIS 6, which makes the .NET the .NET server a very secure server. Before we do that, we'll also be answering the question, is IIS 5 a secure web server? I'll be taking around an hour's time, so the last 10-15 minutes we'll leave open for questions. If you have any questions, I'll take them in the end. It was unfortunate that Code Red and Nimda hit many of our customers hard. We have heard you loud and clear. We know that your businesses were affected, and let me assure you that you are very valuable to us, and we are working really hard to ensure that these things do not occur in the future. So we went back into analysis mode and we tried to understand what went wrong. Why did it happen? So we learned a couple of things. The main thing that we learned was that Windows 2000 was installed as an application server, and it had a huge attack surface. A lot of applications were installed by default. Many people did not need those applications, and they did not even know that those applications were installed on the machine. People didn't know that IIS was installed in the machine, and to have an unpatched web server in your environment is probably the last thing you would like to have. Windows 2000 also had a lot of soft defaults. For example, IIS shipped executable script directories like MSADC, the scripts directory, and attackers could use the Unicode exploit, for example, to take over the machine. Also, the worker process in IIS ran with a very high privilege account as local system. Local system has access to all settings in Windows. So again, if the person knew of any vulnerability, he could easily escalate or elevate his privilege and take over the machine. One of the main reasons that we think that the attacks were so widespread was that we didn't have an automated way to install patches. The patch management story was not very good. People had a lot of problems. People didn't know where to find the patches. People didn't know what patches to apply. And even when they applied patches, every patch required either a service reset, IIS reset, or it required a service reboot. So every time you do that, that means system downtime, and that means you lose money. Also, there were a lot of machines that were in the closets, in the labs, under the desks, which were not managed and which were not patched. And these were the machines that were worst affected. On the other hand, it's a fact that many of our customers survived Code Red and Nimda in a well-managed environment where they had applied the patches. I know of a major hosting company whose internet-facing web servers were totally unaffected by Code Red and Nimda because they had applied their patches, the security, the service packs, and had kept it in a managed environment, whereas in their intranet, all the internet servers were devastated by Code and Nimda because it was in an unmanaged environment. So I would like to make a small point here. It's an analogy that security is a process. It's not really a product. So the analogy is when you buy a car, you buy your product, but after you have driven it a few thousand miles, you go back to the dealer, you back to the gas station for an oil change. Why do you do that? You do that because you want to make sure that your car runs smoothly and it does not let you down sometime when it goes to the 50,000 mile or 100,000 mile range. So similarly, when you buy Windows, you're buying a product, but security is a process which you have to keep on doing regularly to make sure that you are secure. So to answer the question, is IIS 5 a secure web server? Well, yes, IIS 5 is a secure web server, but in a managed environment. IIS 5 is not secure by default. Yes, we shipped many more patches than we thought we would, but we have learned our lessons, and we are really working hard to ensure that Windows becomes a safe and secure platform. For Windows 2000 and for NT4, we released the IIS Lockdown Wizard and the URL scan immediately after the attacks of CodeRed and Nimda. The IIS Lockdown Wizard basically locks down the additional services that are enabled by default in Windows 2000, and you can enable only those applications that are required by you, and you disable all the applications that are not required by you. URL scan, on the other hand, is an ISAPI filter which scans every request that comes to your web server and denies requests based on the verbs of the request, the headers of the request, the URL sequences of the request, or the file extensions. Also, for the benefit of our customers, we introduce this concept of cumulative patches. Now, what this does is all the security patches after the last service pack are rolled up into one cumulative patch, which has a single reboot. This makes the job of the administrators much easier. But patches cannot solve all issues. We still need to improve, and that's why let's see what we have in IIS 6. So we have given IIS 6 a good security boost. We have implemented all the lessons that we have learned over the last year. So we have reduced the attack surface. We have checked our code, each and every line of the code, to see whether it's secure, whether it has any vulnerability. We have checked our defaults to make sure that they are secure. Also, we now make sure that worker processes run with low privilege accounts and not as local system. And we have greatly improved our patch management story. In addition, we have also improved the security of ASP and have added some isolation features like application isolation, FTP user isolation, and also have added new authentication and authorization schemes. So let's look into all of them in detail. In the .NET server, we have reduced the attack surface. IIS and around 20 plus other services are not installed by default. IIS 6 is now an optional component. So if you need to install IIS, you have to go to the optional component manager and turn it on. Even when it is installed, it is locked down by default. Only web service gets installed, and you can serve only HTML files. So if you need your web server to serve active server pages or ASP.NET, you have to go and enable that in the server. Only then it's going to be served. So to do this, we have introduced a new concept called the ISAPI restriction list and the CGI restriction list. So the ISAPI restriction list and the CGI restriction list basically have a list of all the ISAPIs and the CGIs on your machine. And on a clean install of the .NET server of IIS, all the extensions in this list are disabled. Whereas on an upgrade, if you have any ISAPI or CGI enabled, that remains as enabled on an upgrade, but anything else other than that remains disabled. We have also introduced a new thing called the template-based feature activation wizard. Why this is important? Let's say you install IIS and now you want to run this box as an Exchange server. So how would you know what DLL Exchange requires to run? I mean, either you could read a KB article and see, okay, Exchange requires DLL 1, 2, 3, and then I go and explicitly enable it, but that would be a headache. So what we have done is we provide you templates for all the major servers that we ship, and you can select a template, and depending on the selection you make, it goes and activates the required DLLs for that template to run. Let me give you an example of the new wizard. It's still in development, so I'll be only showing you screenshots right now. So, So when you install your .NET server, the configure your server wizard comes up, and there you're given the option of to choose the way you would like to configure your server. And when you choose web server, while the components are being installed, it pops up the screen, welcome to the IIS software application wizard or the feature activation wizard. So when you click on next, you get a list of all the templates, and you can choose any one of them or multiple combinations of them as you would like your web server to run. So for example, we have out here BizTalk server, Commerce server, Exchange 2000, proxy server. You can choose whichever you want. But then you might want to see what DLLs get enabled when you select a particular template. So what you do is you highlight a particular template, and you click on the details button shown towards the lower end on the right hand side of the box. If you click on it, it gives you the list of DLLs that the ISAPs that get enabled by that template. Once you have made your selection, you click on the next button. When you do that, before it applies the changes and before it enables the ISAP extensions and the CGIs, it shows you the list of the things it will be activating. For example, it shows that all file extensions will be enabled. It shows that active server pages is going to be enabled. Probably your setting requires ASP.NET too. It shows that too. Once you're sure that, yeah, these are the ISAP extensions or CGIs that I'm ready to enable, I click on next. It goes and enables those ISAP applications or CGIs for you, and it completes the wizard. But what happens if you have your own customized application which requires you to enable a few DLLs? You can also create your own template. All you need to do is create a template and drop it in the template directory. So this is how a sample template would look like. I've given an example of an ASP applications template. A template basically has 4 sections: the info section, the ISAP section, the CGI section, and the file extension section. The info section is basically used to show you on the wizard what's the label and what's the description of the template. So you write down ASP application description. It allows ASP applications to run. In the ISAP section, you write down a list of all the ISAPs you would like to be enabled. Similarly for the CGI section. In the file extension section, right now we say it's all. So basically this is going to enable all the file extensions. If you want only a few file extensions to be enabled, like for example HTML and GIF, JPEG, you can just say that. The remaining will be disabled. Or you might want to say that I want to disable enable everything, but disable just .config files. So this is how you work on the template. So in addition to the wizard, we also thought that it would be helpful to the advanced administrators to have something in the MMC. So we have added a new node in the MMC called the functionality node, which allows the advanced administrators to go at a more granular level and enable ISAP extensions or CGIs. So here we see the functionality node, and if you click on it on the right pane, you get to see the list of ISAP extensions. So out here we have highlighted front page 2000 server. So when you single click on it, you get to see front page 2000 server. You get to see here. You get to see here the front page, the description, the title of the server. Then you have an enable button out here. Why do you have this? Because right now front page 2000 server is disabled. So if I click on enable, it will get enabled. Also we have a short description. Now if you go again to the highlighted area and do a right click, you get a menu out there where you can either enable the DLL, you can remove the DLL, you can see the properties of the DLL. So what else? Out here you see an add new button. So what happens is when you install a new ISAP DLL and you store it on your server, you would also like to enable it. And to do that, you have to add your DLL to the ISAP or the CGI restriction list. To do that, you click on the add new button, and it pops you a screen where you will add the name of the DLL, the description of the DLL, and the path of the DLL. And when you click OK, it will not only add it to the restriction list, but it will also enable the ISAPI or the CGI for you. If you do a right click on the functionality node, you get to see two options. The first is the Run IIS Software Application Wizard, and the second one is the Configure File Extensions. So why would you run the Software Application Wizard again? Like, we spoke to different segments of our customers, and people said that probably the advanced administrator might not use it, but the novice administrators might use it. So let me give you a scenario where this can be put to good use. Like, there is one web server which you have been running as an Exchange box, and now you decide that you want to move the Exchange box to some other web server and run this box as a front page server. So what do you do now? You run this wizard again. It disables all the functionalities that were required by Exchange and turns on the functionality which will be required by front page. So what you're doing out here, you're making sure that your attack surface remains as small as possible. You enable only the functionality which is required by you, nothing more. If you click on the Configure File Extensions, you come to the page where you are allowed to configure which file extensions you want enabled, which file extensions you want the web server to serve. And as I said earlier, you can either disable all applications and just enable all extensions and just enable a few, or you could enable all the extensions and just disable a few. Okay, coming back to the we wanted to make sure that the .NET Server code base is a very secure code base. So we are going through each and every line of code, and we have also introduced a couple of automated tools to make sure that we do not miss anything when we do a manual check. For this, we have used the prefix tool and the prefast tool. The prefast tool is basically being used by all the developers before they load their code into the build tree. So basically, the prefast tool checks errors like buffer overflow, result violations, and so on. The prefix tool, on the other hand, is run in the labs over the entire code base at regular intervals, and the kind of bugs it finds are bound violations. It checks for the return values, and it also does checks on the memory management. We have also added the /gs option in the Visual C++ compiler. What this does is this adds a canary to the stack. So before the return address is executed, it checks whether the canary has been tampered with by anyone. Was there a buffer overflow? So if it finds that the canary has been untouched, it continues with the processing. But if it finds that the canary has changed, it exits the process. But then you might say, if it exits the process, I can see a denial of service attack there. But then what do you think is better, a denial of service attack or a hacker taking over your machine? And again, from the denial of service point of view, with the new architecture in IIS, if a process keeps on crashing at regular intervals, let's say 5 times in 10 minutes, it enables a rapid fail protection feature. So what it does, it shuts down that application pool and lets the administrator know that there is something wrong with this process. Why don't you go and check out? Also, we have revised the canonicalization in IIS 6. Earlier, in the earlier versions of IIS, let me give an example what used to happen out there. Did you know that bar.asp is same as bar.asp dot is same as bar.asp : $data. They're all various streams for the same file, which NTFS uses to open the same file. So if I make a request for www.foo.com bar.asp, what happens is IIS scans the request and it searches for the extension. It finds .asp extension out there. It finds that, and then it says, okay, so then it checks in the script map. In the script map, it finds that .asp files are mapped to the handler asp.dll, and it hands over the request to asp.dll. ASP.dll does the processing and sends a response back. Now what happens when a request comes for bar.asp dot? IIS again scans it, finds that the extension is .asp dot. It again checks the script map and finds that there aren't any DLLs mapped to it, so it hands it over to the static file handler. So what the static file handler does, it goes and calls the create file command. So the create file command is basically used for opening a file in NTFS. Now NTFS is smart and it understands that bar.asp dot is same as bar.asp. So it opens the file bar.asp, takes the contents and passes it to the static file handler, and the static file handler passes those contents to the client. So the client now gets to see your application code. Your intellectual property is visible. So this has been turned off in IIS 6. Now when we call create file, we turn off the canonicalization in create file, and we make sure that NTFS does not understand that bar.asp dot is same as bar.asp. So now when a request comes in for bar.asp dot and a request is made to NTFS, NTFS cannot find the file and it returns file not found. As we were going through our code, we found that, and as we were analyzing attacks, we found that 30% of the attacks that took place in IIS took place through a component called ism.dll. So that made us wonder who is using ism.dll. And then we found that no one was using ism.dll. So we removed that piece of code from IIS 6 code base. And this made us think, how many such old codes which are not being used by anyone is lying around in this huge code base? So we are systematically going through the entire code base and removing anything that is not being used, any function which is not being used by any other function in the code base. Another approach that we took was we thought if we analyze the attacks, the different kinds of attacks like the site defacement attacks, the denial of service attacks, and if we see how these attacks work, and then we thought, can we reduce the chances, minimize the possibilities of these attacks by setting the right defaults, by setting secure defaults. So we first concentrated on the site defacement attacks. We found that all the site defacement attacks take place through executable virtual directories, like the scripts, the MSA DC directory. So because people can easily use a Unicode exploit and they can escape from the directory and they can run system tools in the Win32 directory, in the System32 directory. So we have removed all executable virtual directories in IIS 6. Also, if you see, for these attacks to work, you need to execute the EXEs in System32 directories. We found that all the attacks that took place under anonymous user context. So we removed the rights for the anonymous user to run any executable in System32. Now when you think of a site defacement, what really happens? Someone goes and changes the content in the content directory. The data gets changed. And again, since these attacks take place through the web anonymous users, we denied the right access for the anonymous user in the content directories. So we went through all the different directories in IIS, like the log files, the custom error directory, the cache directories, and we set the right settings and the right and secure settings for all these directories. Then we analyze the DOS attack. So how does the denial of service attack really take place? It's basically one of the ways is you kind of send so much of requests to the server that it cannot process it anymore. Like an authentic user cannot get any services from the server anymore. So we found that in Windows 2000, the request limit was 128K, and that could be easily exploited for a denial of service attack. So we reduced it to a 16K request limit now in IIS 6. If you think that 16K is even big for you, you're free to go and make it even smaller if that suits your applications. Also in IIS 5, there was a feature called check if file exists. It was a meta-based property, and it was set to false by default. we have set this thing to true. What this feature does is before the request is passed on to the ISAPI handler, it checks whether the file actually exists in the system or not. So if we have a request for bar.asp dot, before it's handled to the static file handler, it'll check whether bar.asp dot exists. And if this would have been checked, these attacks would not have taken place. In IIS 6, we also have defense in depth. You've already seen a demo of the feature activation wizard, the console, which was the first level of protection where we enable or disable features that are only required by your applications to run. The second layer of protection is URL scan. So the URL scan, as I said earlier, is an ISAPI filter which checks for every request that comes to IIS, and here you can deny access based on headers, verbs, and URL sequences. URL scan will be installed by default on a clean install of IIS, and also if you have run your lockdown wizard in a previous version and you have upgraded. What is the advantage of URL scan? Let's say that there is, God forbid, but let's say there is a vulnerability in the future. It takes us some time to come out with a patch because we have to make sure that we are fixing it at the right places, because we might find a vulnerability at one place, but there might be similar vulnerabilities at other places. So we make sure that we go through the code again to see that there aren't any similar vulnerabilities anywhere else. And we also need to make sure that we do not break any other components with this patch. So this testing requires some time. In the meantime, your machines are unsecure. Probably this worm or this vulnerability can be stopped by just putting a small deny URL sequence, a URL sequence in this denied URL sequence list. So if we release that, all you've got to do is put it in this INI file which is used by URL scan, and you'll be safe. And again, as I showed earlier, we have added this concept of extension restriction list, which is used to enable or disable extensions like .config, .asp. So you can choose what extensions you want to serve. ASP2 has seen its share of security improvements. We have solved the F5 attack. The F5 attack is a very simple attack, but it was a very difficult problem for us to solve. So what happens is when you make a request from your client browser to the server, the request comes, an ASP request, the request comes into the server, it sits in the ASP queue. The ASP engine picks up the request from the queue, processes it, and then sends a response back. What happens when I press F5? When I press F5, the previous request gets disconnected and a new request is sent. So while the ASP engine was processing it, a new request comes and sits, and when the ASP engine has finished processing it and wants to send the response back, it finds that the process is disconnected. What happens if I keep on pressing the F5 button, or I just keep a rock on that F5 button? I send a series of disconnected requests to the server. Now the rate at which these disconnected requests are going to the server is much more than the rate at which the ASP script engine can process the request. So very soon the ASP queue is full, and a legitimate user cannot use the services of the server, because when he makes a request, he gets the message back, server too busy. We have fixed this bug or this attack in IIS 6. Also, we have solved the problem of hang detection, because we have solved the problem of hanging. Many times there were applications which used to get hang, and the administrator did not know for a long time that the applications have got hung, and it used to affect other applications too. So what we have done now is ASP now can detect that it is in a bad state, that it is in an unhealthy state, that probably some kind of attack is going on, and it can tell the worker process which is running it that I'm not healthy, please recycle me. So if health monitoring is enabled, the worker process gets enabled, and ASP starts running again. This calculation is basically done, it's a complex algorithm which uses the size of the queue, the number of requests in the queue, the number of threads that can be spawned, how many threads have been spawned, how many of them are hung, and using that, this calculation is done, and on the basis of that, it decides whether it should ask for a recycle or not. For ASP2, we checked whether we had secure defaults. So we reduced the response buffer limit to 4 MB per applications. So the moment the response buffer is full for our application, the moment it hits the 4 MB mark, we flush it out, we send the data back to the client, and again, the additional part comes again in the same buffer. Also, we have set the ASP-enabled path metabase property to false. It was set to true in earlier versions of the OS and earlier versions of IIS. No, it's not in 5.1, but 5 and 4. What this does is it allows an ASP application to escape from its relative directly, so it can traverse up the directory chain. So this again is a security vulnerability. So we have fixed that default. Earlier, in IIS 4 and 5, the worker process used to run as local system by default. And as I said, local system is a very powerful account. It has access rights to everything in Windows. So now we run the worker processes as with lower privilege accounts, which do not have that much privilege rights as local system. So we have created some new accounts like network service and local service. While local system had 22 privileges, including TCP, which was one of the most powerful privileges, network service has only 5 privileges, whereas local service has only 3. The main distinction, if you notice, between network service and local system is that local system belongs to the administrators group, whereas network service belongs to the user group. But if you feel that you probably need more privileges than network service, but less privileges than local system, we now allow you to configure the worker process such that you can make it run with your own identity. So let me give you an example. I'll give you an example later on to a demo. But this has some application considerations, because some applications might have been written which required it to run as local system. So you need to go back and see whether there are any applications that require local system and make changes in the code. The .NET server will be providing APIs to make sure that this can be done. Also, in the .NET server, digest authentication ships with 2 implementations. The one which is installed by default is the .NET version of digest authentication, which if you use, you can run your worker process as network service, but the only limitation, or probably for the short time, is that it requires a .NET domain controller to run. Because now we have moved the functionality from IIS to the .NET, the DC area. But if you want the legacy digest authentication to run, you have to run as local system. So this is a vulnerability. I'm sure it'll take you some time to go to a DC, but I think you should go to and run as the .NET version of digest authentication. So let me give you a demo now. To take this one. Okay. Okay, out here we see that there are 2 application pools. Let's see, the Coke application pool and the Pepsi application pool. So what happens when the Coke application pool has an application called Coke.asp, and the Pepsi application pool has an application called Pepsi.asp. So what happens if I run it now? So let me open it. Coke. So I press F5. It shows that it runs and it shows this is a Coke site. And similarly, if I run Pepsi, it'll show you this is a Pepsi site. Now, if I go to the task manager and I see that there are two worker processes running out here, they are running as network service. If you see here, network service, network service. Now, I will show you a demo where you're going to configure it as you want it to be. So let's go to computer management. Okay, let me come here. Okay. So here in the users group, we find that we have two user identities out here. One is we have the Coke worker process identity and the Pepsi worker process identity. So let us now run the application pool for Coke with the Coke worker process identity. So what we need to do for that is, firstly, we have to add the Coke worker process identity to a group called the IIS WPG group. I'll explain to you why we need to do that later. So I add, so it was Coke underscore worker process underscore ID. So I apply that and I'm done. The next thing that I do is I come to the Coke application pool, I do a right click, I go through the properties, and in the properties page I select the identity tab. Right now it is running as network service. I want it to be configurable. I want it to run as Coke worker process identity. Once I have done that, I click OK. Right now, for this to work, we have to do a IIS reset, but this is a bug which has been filed. So before we ship, we are going to fix it. So we do a restart IIS. Okay, we are done. So now let me run the two sites again. So Pepsi.asp and where's Coke? Coke.asp. I do an F5. Now let me go back to the task manager and see what they're running as. So here you see that one worker process is running as Coke underscore worker process underscore identity, whereas the other one, let me see. I don't think I clicked it. Should be running as network service. I don't know where it's gone. So basically, you have now configured a worker process to run with your own configurable identity, which is the Coke worker process identity. So coming back to the slideshow. Patch management. So as I said earlier, the problems that people faced with patches were, number one, they didn't know where to find the patches. Number two, even if they found the patches, they didn't know which patches they need to apply. Number three, whenever they needed to apply a patch, it causes service reset or it causes server reboot. And number four, there were many corporations who didn't want their employees to directly go to the public Windows Update site and grab a patch and apply it on the machine without it being tested with the environment. So what have we done? We have, in IIS 6, with the new architecture model, we have got this new feature where you can install patches without any service interruptions. Most of the patches come in this category. So what happens is when you drop a security package in, it immediately calls for an application pool recycle, And what this does is the worker process picks up the new DLL, and when it recycles and when it runs again, it picks up the new DLL and runs. And so you are applying a patch without any service interruption. The user does not even know that a recycle took place and that you applied a patch. Auto Update team is working really hard to make sure that the .NET server has a good patch management policy. Right now they are going to provide us with 4 options. And the first one is notify me whenever there is a patch. You don't download it, you just tell me that there is a patch available and where I should go to get that patch. The second option is you download the patch and tell me that you have downloaded it and I'll install it at the time I want to do it. You don't install it for me. The third option is scheduled install. What happens out here is Auto Update will download the patch for you and will install the patch at a time decided by the administrator. So if I'm an administrator, get to decide when I want to install the patch. For example, I might have a policy that every 4th Saturday in a month, I pull this machine out of the internet, and that's when I apply my patches, or I have a planned system downtime. So I can say that on Saturday at 2 o'clock in the night, I want you to apply the patch. Auto Update will apply the patch for you then. And the fourth option is immediate install. It's still not yet implemented. It's still in design. So what happens here is it uses the IIS patches which do not require service interruption, and it goes and it will install the patch on your machine the moment it is downloaded. Now, not all patches are going to be installed through immediate install. Patches which are most critical, the most critical security patches. Secondly, patches which do not cause any service interruption. And third, patches which will not break any third-party application, something which is totally internal to our worker processes. But if there is even if you enable immediate install, if there is a patch which has even a remote chance of a service reset or affecting any third-party application, it is going to be downloaded and it's going to be installed as per scheduled install, where the administrator decides when he wants to install it. So as I said earlier, the fourth problem which I listed was big corporations did not want their employees to go to the Windows Update site and download a patch without testing it. What they wanted was that they wanted to first download the patch from the Windows Update site, do extensive testing on it, be sure it doesn't break any applications, and then put it on some server inside their corpnet, behind the firewall, from where all the machines pick up the patches. So they wanted a mini Windows update inside their corpnet. This is exactly what Windows Update Corporate Edition does. So now even the corporations, the intranets, get patched. We have also introduced resource-free DLLs. What this is earlier we had all the localization resources attached with the actual implementation of the DLL, and this increased our turnaround time for patches. So what we have done is we have isolated the resources, and our turnaround time has decreased a lot. IIS 6, because again of its new worker process, provides a lot of security through isolation. It provides true isolation, sandboxing, and quality of service. We'll be looking into that a little later. Also, it provides total FTP user isolation. Even that is covered in a later slide. One thing that hosters generally want to do is they want to store their content in a file server on a different machine, which is not on the same machine as the web server. So for this, it generally requires delegation. Earlier, delegation did not work on all protocols. Now delegation works across all authentication protocols. Also, we have additional security through constrained delegation. What this means is that you can choose which services you want to use this delegation. Like I can say the HTTP service only should use delegation. I don't want FTP service to use delegations. This is constrained delegation. So application isolation. Out here, the worker processes can now be confined to the root directory through ACLs. So what does this mean? So continuing with the example of the Coke and the Pepsi website, I can now create for the Coke application pool, I can make the worker process run as, let's say, the Coke base identity, and also say that the anonymous users will run under Coke anonymous. Similarly, for Pepsi, it can run, the worker process can run as Pepsi base identity, and the anonymous can be Pepsi anonymous. So what this does is, now, if you ACL the contents right, if you ACL the folders right, the Pepsi folder is ACLed so such that it only allows access to Pepsi anonymous and Pepsi worker process identity, then whatever application Coke keeps in its website, it cannot access the stuff in the Pepsi directory because they are ACLed. So you are basically achieving total isolation. Remember earlier in the demo I said when you have your own configurable worker process identity, you have to move it to a group called the IIS worker process group. Now what this means? Since out here we say that you have to ACL the directories, it is not possible for everyone to know what directories I need to ACL for my worker process to run, because I need to access the metabase, I need to access the registry, I need to access the cache directories. So what are the right settings? What are the right ACLs? So for that, we have created this IIS WPG group, which has the right settings. All you need to do is drop the worker process, the identity into this group, and everything will work fine. Drink some water. In IIS 6, we have total FTP user isolation. FTP server 6 has been included in the .NET server. It basically works in 3 isolation levels. One is the compatibility isolation level or no isolation. The second is the small business or the standalone isolation. And the third is the enterprise isolation using AD integration. The compatibility isolation level or no isolation is same as it was earlier with FTP 5.1. So here, under the FTP root folder, a user can have different home directories, but they are not really isolated from each other. So a user A can peek into the home directory of user B. In the second isolation option, where this is the small business, you have total isolation between home directories. They are all under one FTP root directory. So the user cannot peek into somebody else's. But the virtual root directory, there is a virtual root directory where you can store all your shared content, where all the users from their home directory can access. The third option is the enterprise isolation using AD integration. It is similar to the second one. The only difference out here is that the credentials are now stored in an AD box, in an Active Directory box. So you have to connect to AD box to get the information about which remote share you want to connect and what is the name of the user directory in that remote share. So basically it gives you 2 pieces of information. And again here you have a shared virtual root where you can store your shared content. Passport authentication. We have integrated passport authentication now with the .NET server. So one of the problems that people faced was that you go to a website and you have to enter your username and password. You go to some other website, there's another username and password, because probably you would try to use the same username, but someone else had already taken that username. So it would be great if I would have a single sign-on with which I could access any site. So that is where passport authentication helps, and we have integrated passport with the .NET server so that application programmers can make use of this authentication scheme. So if a particular site wants the authentication to be done using passport, they have to register with passport.com, and also when they come to the authentication screen out here, you have to disable anonymous and the other thing and enable passport authentication. This entire process takes a couple of days, and once you're done, you're set. You can also ACL resources with passport accounts now, because since it is integrated with Windows, you get tokens. Password credentials are now mapped with 82. When we were analyzing the .NET Server platform, we found that we did not have any authorization model which made it easier for application developers. We found that the ACLs are too static. They are too object-driven. And what people really want now are business applications which are task-based. I can decide I should be able to authorize based on business rules. So that's why we implemented the URL authorization process, and which we call the .NET authorization framework. So what happens here is when a client makes a request, the request comes over the internet, it comes into IIS, so we first apply the metadata, we do the necessary authentication, whichever you have selected, and then before it is routed to the handler which is going to handle it, so if you make an ASP request, before it goes to ASP.dll for processing the request, we redirect it to the .NET authorization framework. So what this does is it then checks the request against business rules. So it checks the user credentials against some business rules, and if all the criteria of the business rule are satisfied, it transfers control to the handler which is going to serve out the file extension you have requested. But if any of these conditions are not met, access is denied. Let me give an example. For example, there is some financial spreadsheet, and different people in the organization might get to see different parts of it. For example, if it's a VP, he might get to see the entire spreadsheet, but if it's a middle-level manager, probably should get to see only a part of it, not all the details. And if it's an intern, he should not get to see any part of it. So the user logs in, the user makes a request, we check the credentials, yes, he has the right credentials, and then it goes to the authorization framework and we check, does this person have rights to see it? Yes. Okay, how much does he get to see? What is his designation? He's a VP. Oh, he gets to see everything. So I make a change in the URL and I send the changed URL now to ASP.dll, and ASP.dll now does the processing based on that. Similarly, when a middle-level manager comes in, the request comes in, I again check what his rights are, and based on that, I again change the URL, and I'm sending it to the handler again. So what we do internally in IIS is we have added something called the wildcard script maps. What this thing does is when it goes to the script map, before it goes to the script map part where it checks that ASP is mapped to ASP.dll, it checks whether any wildcard script mappings have been done. So the wildcard script mappings are basically DLLs which have the absolute right of processing before they handle to any handler. So that feature is used in the .NET authorization framework. So finally, let me reiterate a few key points. Make no mistake, we are totally committed to Windows 2000, IIS 5, and Windows NT, IIS 4. We have learned our lessons. We are doing our best to make sure that Windows is a very secure platform, and security is the #1 priority for us at Microsoft. You have seen the new features of IIS 6, and let me assure you that IIS is a very secure web server. Thank you. Any questions? Yeah. Oh, sure. So what happens is when you make a request from your client to your web server, if that site supports Passport, it sends you a redirect for the Passport sign-on page. So it basically what it does, it encodes the site ID for that site, the site unique ID which has been given to them by passport.com, and sends the return URL, which is basically the URL which you have requested for, and sends that encrypted to passport.com. Now, passport.com then sends you the sign-on page. It sends the client. The client then enters his credentials, and again it is sent back to passport.com where the actual validation, authentication is done. Once that authentication is done, passport.com will drop a few cookies which enlists the profile of the user and that it has been authenticated, and it sends an encrypted key. It sends basically a PUID, which is called the passport user identifier. Now this encrypted key, this thing is encrypted and is sent back to the site which you requested because it knows the return URL. Now then this URL sees that this is a valid client and allows you in. If you want, you can go to the passport.com site, and there is a link which tells you how it works in great detail with all diagrams and also.
When you were speaking about patch management, you said that corporates want to have their own Windows update site for after they test the patches and everything. Does that come with the .NET server? Does it ship right away out of the box, or is it separate program?
So your question is that you're asking whether the corporate Windows update will ship with the .NET server or not. I am not very sure as to how it's going to ship. It's in development right now, but if you leave me your information, I can get back to you. I'll speak to the marketing guys and I'll get back to you. But it's definitely going to be working with the .NET server.
So that URL scan is enabled by default in IIS 6.
Yeah, it's going to be installed by default. It won't be running by default.
It won't be running.
Yeah. So it's again a design issue which we are working on right now because we are in RC1 phase right now. So we'll be doing performance tests, and we have not yet come to the final decision. I don't know what it's going to be at the end when we ship. But right now, as a security PM, I feel it should be there, but our performance experts say like it might cause 1 or 2% hit because it's a filter.
What I was going to raise is that I mean, cases that I've done on home production service with the first version of URLs, so a substantial.
Yeah. So right now, I think if we draw a compromise, we probably might just install it on the machine, and it's going to have let's say a clean INI file because there aren't any vulnerabilities in the .NET server. So if in case in the future there is a vulnerability, we probably might set a flag to enable it. So right now, yeah, it's a decision which we have to take, but most probably it's just going to be installed, not enabled.
What about tools for, I mean, it's fairly easy to script anyway, but for those who don't or want to put this into operation quickly, what about tools for enabling URL scan across a whole server farm or a large number of servers?
So your suggestion is like, are we working on some tools to enable it?
Yep, maybe just command line tools to enable it remotely on a whole set of servers. Very useful.
Yeah, so I'll take it back to the team. Thanks. Any other questions? Okay, thank you.